Hello, so we're ready for lesson 1.2 today. Let's take a look at what we're going to learn in this part of lesson topic 1. We're going to identify proper and improper fractions, look at mixed numbers, and then we'll be changing improper fractions to mixed numbers and mixed numbers back to improper fractions. So first up, let's talk about proper and improper fractions and mixed numbers and what those all look like. These images can really help you. When we think of a proper fraction, proper means that we have something larger. Our denominator is larger on the bottom than our numerator. So you can see in our first image we have a smaller person being held up by a bigger person. So that's really what a proper fraction would look like. So for example, 1 over 2 or 3 over 4, where our denominator is larger than our numerator. Improper fractions are the opposite, where we have a smaller person holding up a bigger person. So that's where we would maybe do the inverse or flip the fractions. For example, 4 over 3 is an improper fraction. But we also can have where the fraction numerator and denominator are the same. So same size, 4 over 4. So that is considered to be an improper fraction as well. And we'll learn that 4 over 4 is equal to 1. So those two types are improper fractions. Mixed number is a combination of a whole number and a proper fraction. So we have 1½ oranges, so we have one full orange and half of another one. That's considered to be a mixed number. So the three types: proper fraction is where our numerator is less than our denominator. Improper fraction is where our numerator is greater or is equal to or than our denominator. And the mixed number is a combination of a whole number and a proper fraction. So just some random examples of proper fractions back up here where our numerator is less than our denominator. 3/8, 1/2, could be huge numbers, 128 over 129, 128 129ths, and let's say 2/3. Those would be our proper fractions. Improper fraction, it would be the reverse or inverse of some of these above. So for example, 8 over 3, 2 over 1, and then we could look at 15 over 4, 17/17, so they can be equal to each other as well. And then mixed numbers where we have a whole number, for example 2, and a little bit more, a proper fraction 2 3/4, or 5 11/16, for example. Those would be our mixed numbers. So we're going to do some of the questions together for 1.2a on page 15. So we're going to name these as proper, improper, or mixed. Number 1, we see our numerator is greater than our denominator, so this is an improper fraction. Number 2, 4 2/3, we have a combination of a whole number and a proper fraction. This is a mixed number. Number 3, 11/11, remember that improper fractions can have equal numerator-denominator, so this is improper. And number 4, 7/12, our numerator is less than our denominator, so this is a proper fraction. Okay, so now we know a little bit about proper, improper, and mixed. let's talk about changing improper to mixed and mixed to improper. So first up, we're going to change improper fractions to mixed numbers. Now, improper fractions are fractions that are equal to 1 or greater than 1. Okay, so those are our two kinds. 17/17 is equal to 1. 18/17 is greater than 1. So all of these examples here that they provide are improper fractions. So when we want to change an improper fraction to a mixed number, we need to follow a process. And the process really involves division. So we're going to be dividing up. And I'm going to show this as long division as well for those of you who like that kind of visual tool. I'm asking myself, how many times does 5 go into 13? So as a long division, this is what I'm looking at. Okay, so I'm going to divide up. How many times does 5 go into 13? Well, it goes 2 times. So it goes 2 whole times, so that becomes my whole number. And then my remainder becomes the numerator of my fraction. So 5 goes into 13 2 times. 2 times 5 is 10. So I'm going to subtract, and I'm left with 3. So my leftover becomes my numerator, and my denominator is the same as what I started with. My denominator is the 5. So 13/5 is the same as 2 3/5. So just to label this for you, this becomes my whole number. How many times does 5 go into 13? The remainder becomes my numerator. I have 3 left over. And my original denominator, what I'm dividing up, stays as my denominator always. So let's take a look at the exercise 1.2b do together, and we'll do these two questions together. We're going to convert improper fractions to mixed numbers. So we're going to do that by dividing up. How many times does 3 go into 8? 3 goes into 8 2 whole times. 3 times 2 is 6, so when we subtract 6 from 8, we get 2 as a remainder. This becomes my numerator. So the 2 left over becomes my numerator, and what is my denominator? My denominator is the same as it always was here. It's out of 3. So 8/3 is the same thing as 2 2/3. Let's try one more. Number 2, we have 47/15. Our strategy doesn't change. We're dividing up. How many times does 15 go into 47? In this case, 15 goes into 47 3 times. 15 times 2 is 30. 15 times 3 is 45. So when we subtract, we're going to be left over with 2 remainder. So 15 goes into 47 3 whole times with 2 left over out of the original 15 denominator. Okay, so again, numerator is our leftover. Denominator doesn't change. And this 3, how many times it goes in, is the whole number. So we have now converted improper fractions to mixed numbers. The last part of our lesson is to do the reverse. We're going to convert mixed numbers to improper fractions now. So we know now that mixed numbers are a combination of a whole number and a proper fraction. So we're going to follow a process, and we call it the C method, okay, because it looks like a C. So what we're going to use is our C method to convert 4 2/3 to an improper fraction. So we're going to take 3 times 4, which is 12, and then we're going to add the numerator. So our C method goes from the bottom up. 4 times 3 is 12, plus 2 is 14. And just like we learned in the last section, the denominator doesn't change. The denominator stays as 3. So 4 2/3 becomes 14 over 3. When we changed improper fractions to mixed numbers, we did division. When we changed mixed numbers to improper fractions, we are multiplying and adding. Okay? So let's take a look at the do together. We're going to convert the first 3 to improper fractions using our C method. We're going to multiply denominator by whole number and add our numerator. 3 times 3 is 9, plus 2 is 11, over 3. 3 2/3 is equal to 11/3. For number 2, we're going to use our C method. 6 times 7 plus 4, or 7 times 6. So 7 times 6 is 42, plus 4 is 46, over same denominator, over 7. 6 4/7 is equal to 46/7. For number 3, same thing, C method. 5 times 5 is 25, plus 3 is 28, over 5. For number 4, it's a little bit different. It says state the fraction which represents the shaded part of the object. Okay, well what we have here is we've got one whole, right? We can see one whole thing is shaded. So that's 1, and then let's set up our fraction for the second one. 1, 2, 3, 4, 5, 6. It's divided into 6 pieces. 5 of them are shaded. 1 5/6 is our mixed number, but what if we wanted to make this into an improper fraction? If we wanted to make this to an improper fraction, we would use our C method. 6 times 1 is 6, plus 5 is 11, over 6. So our improper fraction doesn't have a different denominator. It's not all of a sudden out of 12. So if you wanted to count this without having a mixed number, you could say, well, one figure is out of 6, and I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 parts shaded out of 6 because one single figure is divided into 6. So either way, 1 5/6 or 11/6, those are both correct answers for number 4. So you can try the rest of the exercises for lesson 1.2, and then you'll be ready to go on to 1.3. Take care.